In today's video, we'll be going over through how to use the power rule. Well, a basic example of the power rule, or a basic question in which we can use the power rule, would be 3x to the fourth. This is just basic, so we're going to lay out the basic rules for this type of problem. The first step is to make your exponent, I'm just going to put exp for exponent, the coefficient, and then you can multiply if you already had a other coefficient. So multiply when needed. Okay, now our second step is to decrease our exponent after we completed step 1. So decrease exponent by 1. So you're just subtracting your exponent minus 1. So let's go ahead and do this example right here. So here we have 3x to the fourth, and we need to follow our first step, which says make the exponent the coefficient and multiply when needed. Well, we can see that we already have an exponent, so we're just going to have it like this with 3x, and we're going to make our exponent, which is 4, our coefficient. So we have our 3x, and we left it intact, and we're going to put our 4 as our coefficient. Now, let's go and do our second step, which says decrease your exponent by 1. So we have an exponent of 4 minus 1. Well, now let's go ahead and simplify this. So we have 4 times 3x, which is just 12x. And then we have our exponent, which is 4 minus 1, which becomes 3. This means that the derivative of 3x to the fourth using the power rule is 12x to the power of 3. This was one of the more basic problems. Let's go on to a more challenging problem. So let's go ahead and start with fractions. So these are going to be rules when we are dealing with fractions. So in dealing with fractions, the x is in the denominator. And you'll see what this means when we start doing our problems. And you're going to know when you have a fraction is when you have an x to the power of a negative exponent. So when x is to a negative exponent, you're going to have a fraction. That's something to just keep in mind. So now you're going to, again, so your x goes into the denominator. So it'll look something like 1 over x when x is to the power of negative 1. So it'll become a fraction. And then our second step is similar to our first steps, where we make our exponent the coefficient, and again, multiply when necessary. Next, we have step 3, which says decrease your exponent by 1 or subtract by 1, which, as you know, is similar to our basic rule. So decrease exponent by 1. Step 4 is to make the numerator the coefficient. And again, you'll see what this means when we do our problem. And again, multiply when necessary. All right, let's go ahead and do a practice problem. So our first practice problem for the fractions is going to be 4 over x. So 4 over x. So now we know that whenever we have a fraction, x is being raised to a negative exponent. So here, we're going to raise x to the power of negative 1 because we want to make it 1 over x. We don't want to worry about the 4 just yet. So right now, we're just looking at the x and how we can make it a more easy to work with form. So we have x to the power of negative 1. Now what we're going to do is we're going to follow step 2, which says make the exponent the coefficient. So we have x, so we have negative 1 times our x, and it's still to the power of negative 1. So now it says, step 3 says to decrease exponent by 1, so negative 1 minus 1. So let's go ahead and simplify this down. And you can see this is really similar so far to our first problem. So we have negative 1x, or negative x. And then we have negative 1 minus 1, which, as we know, is negative 2. So now that we have negative 2, we're going to worry about our 4 in our numerator. And in step 4, we said the numerator becomes the coefficient. This means that we have this, and then we have our coefficient, or our numerator becomes our coefficient. And remember, our numerator was 4, So we have 4 as our coefficient. 4 times negative x to the power of negative 2. And 4 times negative x to the power of negative 2 is negative 4x to the power of negative 2. And we never want to have a negative exponent. So we are going to do and make this a fraction. As we said, when we have a negative exponent, it becomes a fraction. And here, since we have a negative exponent, but we have a 2 instead of just a negative 1, we're just going to have a positive x squared in our denominator. This means that we're going to have a positive x squared in our denominator. Let's see what this looks like. So we're going to have our coefficient goes back into our numerator. So we have negative 4 over, and this negative is basically what made the fraction. So we get rid of the negative, and this makes it negative 4 over x squared. This means, using the power rule, the derivative of the fraction 4 over x is negative 4 over x squared. Now let's go on to the next set of steps, which is for roots. And in roots, let's use a better color. So for roots, let's use orange. So we have roots. And in roots, the first step is the type of root, like square root, cubic root, etc., equals your exponent, or whatever your exponent is, the value. For example, if you have x to the power of 1 over 2, this means you have a square root. And we'll get into that in our practice problem. And the base form you should remember when dealing with roots is that n root of x to the power of m equals x to the power of m over n. So our second step is to make the exponent our coefficient. And again, this is from our first and second steps we had just gone through. So make exponent, exponent the coefficient. Our third step is again the same. Subtract exponent exp by 1. Okay. Next, we have our fourth step, which says simplify when needed. And again, we'll see when this is used in our problem. And then fifth step says make negative exponents into fractions. Make negative exponents into fractions. Okay, so now let's go ahead and do a practice problem with this, with roots. So here, you have a practice problem for roots which says 5 over 6 cube root of x. And we want to find the derivative using the power rule, and we're dealing with roots, so we're going to follow our steps. So the type of root equals our exponent. Well, remember, as I said, and I'll write this as an example. So we have x to the power of 1/2. This just equals square root of x. And we can write roots equal fraction exponent. So when you have a fraction exponent, you should be already able to determine that this is our root. So we have the cube root. So using the logic that x to the power of 1/2 is square root of x, we know that x to the power of 1/3 is the cube root of x. So this second part just became x to the power of 1/3. Now we're not going to worry about the 5 over 6 just yet. We're going to finish our steps, and then we'll get into the 5 over 6. So now we have x to the power of 1/3, and let's follow our second step, which says make the exponent the coefficient. So let's just do that. So we have 1/3 times x to the power of 1/3. Subtract our exponent by 1 in step 3. Okay, no problem. So now we have 1/3 x to the power of 1 over 3 minus 1. And this 1 is essentially 3 over 3. So we have 1 over 3 minus 3 over 3, which equals negative 2 over 3. To the power of negative 2 over 3. And now, remember that when we have a negative exponent, we are going to make it into a fraction. And now if you remember from our fraction step, when we have a negative exponent, it becomes a fraction. So we have 1 over the power of x to the power of 2 over 3. The negative just goes away because it made the fraction, and our exponent becomes positive. Now we're going to multiply that by our coefficient, which is 1 over 3. And this just becomes 1 over 3x to the power of 2 over 3. Simple enough. But we're not done just yet. If you remember, we had that coefficient up here originally of 5 over 6, and we're just going to multiply that in. So we have 5 over 6 times this, which is 1 over 3x to the power of 2/3. And we're just doing simple multiplication. 5 times 1 is 5 over 6 times 3, which is 18x. And we're just carrying this guy over, x to the power of 2 over 3. So 5 over 18x to the power of 2 over 3 is the derivative of 5 over 6 cubic root of x using the power rule. Let's go ahead and do one last problem dealing with the power rule, and this one is again going to be with roots. So in this last problem, dealing with roots, we have x to the power of 5 plus 10. And in this problem, let's go ahead and deal with this square root of x to the power of 5. And remember, when it's just a square root, we're just raising it, whatever's in the inside, to the power of 2, or 1/2, because remember, fraction exponents equal roots. So we have x to the power of 5, let's make that a 5, to the power of 1 over 2. Now that we've simplified it down to x to the power of 5 to the power of 1 over 2, when we have an exponent and an exponent, we're essentially multiplying. So we have x to the power of 5 times 1 over 2, and we know that is x to the power of 5 over 2. So now that we have x to the power of 5 over 2, now let's go ahead and follow our steps. So we're going to make this our coefficient first. So we have our coefficient of 5 over 2 times x. Okay, so that's just 5 over 2x raised to the power of 5 over 2. Remember, we have to subtract 1 from our exponent. So we have 5 over 2x, and this 1 is essentially 2 over 2, and this is 5 over 2 minus 2 over 2, which leaves us with 3 over 2. Okay, so we have 5 over 2 to the power of 3 over 2. And if you remember, when we have a fraction exponent, we have roots. So remember, the base form for this was n square root of x to the power of m equals x to the power of m minus n. So we have this form right now, where we have x to the power of 3 over 2. We don't want to worry about the coefficient of 5 over 2 just yet. So right now, let's make this into a root. So we have our n, so we can see our n is our denominator, which is 2. So we have a square root. No need to put any numbers here in the radical. So then we have x to the power of 3. So we have x to the power of m. So this is m, this is n. So we have x to the power of 3. And now we can bring our coefficient over. And 5 over 2 is our coefficient multiplying by the square root of x cubed. And again, this is sort of following the steps from our roots. But again, our only thing that we made different here was we had roots and we had fractions and we had to multiply our exponent. And now we have this 10. Well, when we take the derivative of 10, it's not being raised to anything. It just becomes 0. So we can just not worry about this 10. So now we know that the derivative of the square root of x to the power of 5 plus 10 is, as we found out down here, 5 over 2 times the square root of x cubed. If you believe this video helped, please consider to like and subscribe. I'd greatly appreciate it. Thank you.